Imagine, for a moment, absolute nothingness. No space, no time, no matter, just blank. Just void. And then a flicker, a spark, a tiny tremor in the endless dark. It's like the universe just woke up, you know. From that fleeting ripple, an entire universe blossoms into existence. This isn't just some myth or deep philosophy, you know. It's real life. This is the cutting edge of theoretical physics, the quantum origin of our universe. For almost 100 years, the Big Bang Theory has been our go-to creation story, you know. A singularity infinitely hot, infinitely dense exploding outward, forming galaxies, stars, and eventually us. But while the Big Bang explains how the universe evolved, it leaves a haunting question unanswered. What came before? What do you think really kicked off existence itself? What sparked it all, right? Einstein's equations break down at the moment of the Big Bang. Gravity becomes infinite. Time loses meaning. To go further, we must turn to the bizarre laws of quantum mechanics in the quantum realm. Nothingness is anything but empty. At scales 1,000,000,000,000 times smaller than an atom, space itself churns with energy. Virtual particles appear and vanish in a cosmic dance, borrowing energy from the void before disappearing again. This isn't just a theory, we've seen it happen right before our eyes. The Casimir effect proves that even in a vacuum, quantum fluctuations exert real force. So if empty space isn't truly empty, could the whole universe have popped out of that tiny little thing? Crazy, right? In 1980, physicist Alan Guth proposed cosmic inflation, a theory where a random quantum fluctuation triggered a runaway expansion, inflating a subatomic speck into the vast cosmos we see today. But inflation raises another question. If one quantum fluctuation made our universe, could others make different ones? Here's where things get truly mind-bending. The total energy of the universe might be exactly zero. All the stars, galaxies, and dark energy we see could be balanced by the negative pull of gravity, meaning the universe could have emerged from nothing without breaking any laws of physics. Nobel laureate Frank Wilczek put it this way: the universe is the ultimate free lunch. A quantum fluctuation that, through inflation, became everything. But if universes can just pop into existence naturally, what does that mean for us? So, are you saying ours is just one of a whole bunch? If quantum mechanics allows one universe, why not an infinite number? Eternal inflation suggests our universe is just one bubble in a vast multiverse, each with its own laws of physics. Some might have stronger gravity, ripping planets apart instantly. Some folks might not have any atoms at all, just a whole lot of dark energy. Ours, by sheer chance, had the right conditions for life, but how could we ever prove this? Are we forever locked inside our cosmic bubble, unable to see beyond? Some scientists search for imprints of other universes in the cosmic microwave background, strange patterns that shouldn't exist in a single universe. Others look for signs of quantum gravity in particle colliders. If we find tiny extra dimensions or exotic particles, it could support string theory's version of the multiverse. But the hard truth, we may never know for sure. The quantum origin of the universe might remain a beautiful, untestable idea. Yet, even without proof, the implications are staggering. It suggests universes can arise naturally, without a creator, purely from the laws of physics. So where does that leave us? A species on a pale blue dot, trying to comprehend our own existence. If the universe came from nothing, does nothing have meaning? Or is nothing itself an illusion? Some say this makes life meaningless. Others argue it makes our existence even more miraculous, a rare cosmic accident that allowed us to ponder these very questions. Perhaps the answer isn't in the equations, but in the fact that we're here at all, conscious beings in a universe that somehow against all odds, became aware of itself, we may never know the true origin of the universe. But the search itself, the human drive to understand, is what makes science so extraordinary. What do you think? Was our universe a random quantum event? A multiverse inevitability? Or something beyond our comprehension? Let me know in the comments, and if you enjoyed this journey to the edge of reality, don't forget to share it with fellow cosmic explorers. Until next time, keep questioning,